Today I will be explaining a series and sequences. Now, a sequence is a list of numbers in a specified order. So, for example, we could have 1, 2, 3, 4. That is a sequence. Now, there are two types of sequences. First, there are arithmetic sequences, and an arithmetic sequence is a sequence in which the terms increase by a common difference. So, for example, we could say 2, 4, 6, 8, and the common difference would be 2, because from 2 to 4 there's 2, 4 to 6 there's 2, and 6 to 8 there's 2. And the next type of sequence is a geometric sequence, in which the terms increase by a common ratio. So rather than arithmetic sequences where it is addition or subtraction, here we have multiplication. So, for example, we could have 2, 4, 8, and 16. And in order to find the common ratio, you would just take one term and divide it by the previous term. So let's say 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. So the common ratio in this geometric sequence would be 2. So, So a general term in a sequence is the nth term. So n can be any number, and in order to find it, we must notate it as un. So there are two formulas for the sequences. Well, one for the arithmetic sequence and one for the geometric sequence. So if you're trying to find given term, or not given term, general term un for an arithmetic sequence, you would take un and set it equal to u1, which is the first term of the sequence, plus n minus 1, n being the term you're trying to find, and then times d being the common difference. So, for example, in this arithmetic sequence, we would set it up as u1 being 2 plus n minus 1 times 2, because the common difference is 2. Now, for a geometric sequence, the formula looks a bit different for the nth term, or the general term. So you take un and you set it equal to u1, which is the first term, times the ratio to the power of n minus 1. N, once again, being the term you're trying to find. Now, for example, with this geometric sequence, we would set up the equation as un equals 2, because 2 is u1, times 2 to the n minus 1, because u1 is 2, the first term is 2, and the common ratio is also 2. So, we can also find the sum of terms for both arithmetic and geometric sequences. So, an arithmetic sequence is always going to keep going and going and going, because more can always be added to it. The common difference can always be added to it. So the sum of terms in an arithmetic sequence formula is as follows: Sn equals n over 2 times 2u1 plus n minus 1 times d. So u1 once again being the first term and n being the term you're trying to find, and d being the common difference. So yeah, that's that. Or you can also do n over 2 times u1 plus un. So when we do this, we're not trying to find the sum for the entire sequence because the sequence is infinite. So n would be the number of the term of the sums that we were trying to find. So that was worded poorly, but clarification. So if we were trying to find s of 10, it would be, we were trying to find the sum of the first 10 terms in the sequence. So everywhere that you see n, you just substitute 10. And then the formula for the sum of a finite geometric sequence, Sn, n being the terms in the finite sequence, you take u1 and distribute that to the ratio to the power of n minus 1 divided by the ratio minus 1. Or you could also do u1 times 1 minus the ratio to the power of n over 1 minus r. And in both of these, r cannot equal 1. Cannot equal 1. So r cannot be 1. And that is because that would lead to us dividing by 0. So that is the equation for the sum of terms in a finite geometric sequence. Now for infinite, the equation is u1 divided by 1 minus r, where the absolute value of r is less than 1. So it cannot be greater or equal to 1. It has to be less than 1. So that is just some basic background knowledge for series and sequences. Now, I'm going to show you two examples, one of an arithmetic sequence and one of a geometric sequence. So here we have an arithmetic sequence. The first three terms of an arithmetic sequence are 4, 8, and 12. And the goal is to find u30, the 30th term. So we would go about that by first finding the common difference, which we can clearly see is 4. So d equals 4. We can just write that down. And now we have to set up the equation. So un, the equation again is un equals u1 being the first term. The first term here is 4 plus n minus 1 times the common ratio, or common difference, not ratio. So now we have to find u30. So wherever we see an n, we would substitute it with a 30. 30 minus 1 times 4. Now, u30 equals 4 plus 29 times 4. So 29 times 4. 116, I believe. Yeah, 116. Plus 4 would make u30 120. Now, we have to find the sum of the first 30 terms. So, S30 equals 30 over 2 to u1, u1 being 4, plus that. Now I'm gonna calculate that real quick. So let's see. Well, D is 4. We can substitute 4 in for that. I'm having some technical difficulties. I will be right back.